Hello everyone, in this exercise of SolidWorks we will create a rack and pinion assembly in SolidWorks. Let's start. File, new, assembly. We will go in assembly. This one, okay. This is the user interface of SolidWorks assembly. I am cancelling this one and cancel this one. And select the background plain white and the unit system is a millimeter gram second. Okay. Now, first we will create a rack and pinion assembly and later on we will create a animation for this thing. I am selecting front plane sketch. Okay. And selecting the circle. This one. I am taking the dia of 80 mm. You can take your dia as per your requirement. This one. And I'm taking a straight line here. This one. And draw a center line here. Okay. Make one relations. This point, select shift key, this point and this line. Make relation symmetric. Okay. I am taking this line as a 250. Okay. And selecting this distance between this line, I am taking 60 mm. Okay. Cancel out of the sketch. Now this is the task pane. In right hand side, top side, you will see there is a task pane. You go in the design library here. This is a toolbox here. Toolbox, if this not is available in your SolidWorks, you can go from here upper add-ins and you can bring from here SolidWorks toolbox library and OK it. Okay, but I have the toolbox. Click on this one. Now add in now. Click on this. So different standards comes here. So you can select as per any standard. I am selecting ANC metric here. Double click on this. Now you go in the power transmission. Okay. This is the gears. We have to go in the gears. You will see there are the different types of the gears here. I am selecting the spur gear here. Spur gear here. This one. This is a gear. Okay. And now there a new window comes here in left hand side. You have set the parameters for this selected gear. I am selecting module 2 and number of teeth 40. I am taking pressure angle is standard, that is you take 20. Face width you can take 15 or you can take 20, suppose 20 face width. Okay. And hub style, hub is none, and nominal shaft I am taking 30 mm. Okay. Keyway is rectangular and okay. Now you see there another gear is coming on the in the graphic area, but I don't want. I want only one and cancel it. Okay. Now this gear is there. Now we make a relation mat. This one is standard mat. Front plane. Assembly front plane. This is the assembly front plane. And select the face of this gear. This one. And oh sorry. First in assembly, whenever a first part is brought in the assembly area, graphic area, that is fixed. So first I have to make it float, this one. Now make the relation. Mat, standard mat, this one. Select the front plane, assembly front plane. This is assembly front plane and make this surface. This and reverse from here. Okay. And okay, hit the OK button. Now another mat, select this circle. This circle and this board I have. Okay. Make the concentric relation. Okay. This one. two relation I have made, cancel it. Okay, this. Now again go in the design library. Now this time you bring the rectangular rack. I am back this one. Select this one. This part is float. First part is brought in the assembly, that is fixed. That is the inherent. That is first part. But this is float. This is movable part. You will see here. And set the parameters for this module will be same. Pressure angle 20. Face width I am taking. Suppose 20 mm face width. Pitch height I will take 20. Okay. I have set the heights 60, 40 which is the half of the PCD plus 20 is this one pitch height. So total distance will be from center to here will be 60. Length I am taking 250 as per this line. Okay. All components show teeth all. Now another rack is coming, but I don't want, and cancel it. This one. Now make the relation matte. Select this surface and this surface. This is the coincidence relation. Okay. Another relation. Select this line and this line. Coincidence relation. This one. This one. This is this line. This one. Okay. Front plane. Cancel it. Now you zoom it and go in this one, move component, make a collision detection first. This one. Now collision detection. All components stop at collision, highlight faces, sound. Okay. If I move this one, this one, now stop at collision. If you rotate it, this will strike. This will not fall because this is the collision detection. You will see here. Okay, I am taking this position and okay it. Okay, I am taking this. Now I will make a relation here. Make a relation here. That is the rack and pinion relation. Okay. Firstly, I will hide the sketch. This one. This. Okay. Now in the gear section, there is a tooth cut. This one. Show. This is showing. Tooth cut is showing. Okay. Okay. Now matte mechanical rack and pinion pitch diameter option, this one. Okay. Now you select in the rack section, you select this line, this one, and pinion gear relation, you select this outer circle, that is the pitch circuit diagram, this one, and hit OK button and cancel it. Okay. This one. Firstly, properly match the gear in this way. Okay. In this way you match. Firstly, you adjust the space between this thing. This one. This should not overstepping of the teeth. Okay, in this way. And now assembly matte clear mechanical and rack and pinion. Select this line and this outer circle. Select this one. And cancel it. This one is moving. This one is moving properly. Firstly, you adjust the teeth. There should not be overstepping of the teeth on the other. Okay? In this way you can. So, suppose you show the sketch, this one, and hide this tooth cut. This sketch, hide this one. This one. Okay. Now you give the motion and an animation. For animation, you go in the motion study. This is at bottom. You will see motion study. This can you bring. You go in the command manager toolbar. There is a motion manager. If you click it, it will come in at the bottom. Okay, this one. Now I am opening this motion study. Now, firstly, you set the for the time for which you want to make animation. Suppose I take 40 seconds. Okay, then you give the motor. This is the motor. This one motor, you can select this board. You can change the rotation from here, left side, anti-clockwise. Okay, speed you can take 2 RPM. Suppose 2 RPM. Okay. 2 RPM, this one, and this is gear item. This is the motion study properties. Click here, set the frame. Suppose you set the 30 frame. This defines the smoothness of the animation, basic motion. You can hide this low to high, this one. Okay, and this one. Now you set and calculate it. This one. In this way you can also save from here. This animation you can save here. This one, select, name the assembly where you want to save, file name, save the path, and you custom aspect ratio. You can select this one, 16:9 STV format, and select the this is the frame per second. You can select from here. Suppose 30. You want to select 30 and save it. This one. Would you like to save in the video folder? Yes, sir. You can save. In this way you can save it. Okay, and I hope you would have enjoyed in this exercise. You please like, share and subscribe this channel. Thank you for watching. Thank you very much.